All right, next in our notes on segments of a circle, we have the power of the point theorem. So we have three different situations of how these segments are going to interact with each other. So the product of two segments from a point on the circle is constant along any line through the point and the circle. And I don't have a great way. I have a pretty good way to remember these. I'd say it's pretty easy to confuse them, which means that while you do the assignments, you're probably going to want to have this out so that you guys can look at these and refer to them. Kind of like this set of notes and the last set of notes, there was a lot of circle conjectures in here. There's a lot of stuff that's pretty easy to confuse, which means you're going to want to have it out. All right, so situation one is you're going to multiply the lengths together. So the length A and the length B. So you're going to find the product, A times B. And that's going to equal the same product as the length C times the length D. So AB is the same as C times D. These two products are equivalent to each other. All right, similar with situation two, again, we're going to be working with products. So here you're going to have the length of the entire thing, X plus W, multiplied just by the piece on the outside, multiplied just by W. So that product multiplied by this entire length, z plus y, times just the portion that's on the outside. So again, we're talking about a product equals a product. So the whole thing times the outside, the whole thing times the outside. All right. I think of these two as kind of being the same, except for this side, we don't have like an entire side and an outside. So I think of it as t multiplied by t, like, oh, the whole thing and then the outside, but you can just call it t squared. And then again, we have the whole length, so z plus y, and then the outside, the whole length, and then the outside. So I kind of think of these two as being like equivalent formulas here, like the whole thing and then the outside. All right, so let's go ahead and just do these examples. So we've got the whole length here is 14. The whole length here is 7 plus y. So we've got the whole length is 14 multiplied by the outside, which is 6. We've got the whole length, 7 plus y, multiplied by the outside, which is 7. All right, so 14 times 6 is 84. 84 is 49 plus 7y. All right, we can go ahead and subtract the 49 over to the other side. 84 minus 49 is 35. We'll go ahead and divide each side by 7. And then y equals 5. All right, for this one, the entire length here, 16 plus 8 is, what is that, 24? All right, so we've got the entire length z times the outside z, or z squared, you can just say. Z squared equals the entire length, 24, times the piece on the outside, which is 8. Z squared equals 192. 24 times 8 is 192. And then we're going to go ahead and square root each side, and you can just say z equals the square root of 192. I'll go ahead and square root it on my calculator. Square root of 192 is 13.856. All right. So again, we've got the whole length is 34. This whole length is x plus 16. So we've got the whole thing multiplied by the outside, the whole thing multiplied by the outside. So 34 multiplied by 14 is 476. Go ahead and distribute the 16. 16x plus 16 times 16, I believe, is 256. We can subtract 256 on each side. So 16x equals 220. And then we'll divide by 16, divide by 16. And so x equals 13.75. All right, and then last, we've got 3 times 7 equals 6.5 times m. I think the hardest part about these problems is being able to see in the picture, if they drew it too small, being able to recognize what part goes with what little segment. I think that's the hardest part in my opinion. So 21 equals 6.5 m divided by 6.5 divided by 6.5. And so m, I could have put a squiggly equal sign. Well, no, that was exactly 13.75. M is approximately 3.231 because 6.5 does not go into 21 evenly. Is it just a funky decimal answer? That's it.